Greetings. So this is our second year doing NASA Mines for Project ChiliHouse. And so I wanted just to give a little bit of background. Last year we had a fairly robust solution in the simulation. We had a swarmy robot that was able to drive around and water plants within this dome when the plants would report that they were in a dehydrated state. And then we were also using a industrial impedance analyzer to test the impedance of not only the soil, but also of the plant itself at specific frequencies. But this year, we focused on very much removing the need for that industrial impedance analyzer and essentially making our own, utilizing two Arduinos and a PMOD interface to be able to take readings from the various different kinds of plants. So on the right here, we have some sunflowers because they degrade in a much faster state than the chilies. Chilies are fairly robust. That's another reason why we chose them. But in order for testing in nice time lapses like this is just over the course of a day. And so we wanted to very much have a physical robot interacting with physical plants and physical 3D printed pots and seeing how that worked out. And so we found that the swarmies were able to interact with the pots without issue. The sonars bounce off pretty well, and that the swarmies were in fact able to drive up to and water and take care of the plants, as well as driving up to a water reservoir to refill itself.
Hello, this is Aban Samimi Mozlaq. Here you can see an Arduino-based device that can measure the temperature and the impedance of a plant. This impedance measurement module measures the impedance through the cable, which is connected to this probe, and the probe is also connected to the plant. The Arduino Mega Board receives the data from this impedance measurement module and sends the data to this Arduino Uno Wi-Fi board. This board also receives the temperature data from this temperature sensor. Then this Arduino Uno Wi-Fi sends the data to a server. Therefore, the robot can communicate wirelessly with this device.
Hello, my name is Stephanie, and I focused on the second component of the impedance work, where we use this device to hook up multiple connections to our 3 treatments in the sunflower dehydration experiment, which consisted of a soil probe, a stem probe, and a pedial probe. And plant A was our control, which received consistent hydration. Plants B and C were dehydrated over a course of 5 days. And the goal was to see how drying soil impedance values correlate with dehydrating plant impedance values in the various plant tissue types. And with these numbers, we would aim to gather some of the same values with our handmade Arduino components, whether we are looking at the soil with low values for hydrated soil, or if we're looking at plant tissue, such as pedial tissue, which in this case, the dehydrated plant tissues are actually lower.
So we've made some physical modifications to the Swarmy. We've added this water tank here, which is just a standard windshield wiper sprayer, and it's mounted on with just a bent aluminum bracket. And it has a built-in pump, but we're not using it because it has a rectifier, so it only pumps in one direction, and it's also not isolated from what it's pumping, so that can cause the pump to eventually fail if we were to be using it. Instead, we're using a peristaltic pump, which is the kind of pump that you would find used for like pool chemicals and whatnot. And it's very nice because it allows you to pump both directions, and then it also isolates from what it's pumping, so no corrosion or whatnot could occur. And then also it keeps a vacuum seal on, so if the pressure in the tank or the pressure outside of the robot changes, it's not really any big deal. And then we're using the existing pins on the Arduino that normally control the gripper, which would be right here, to drive this H bridge here, which then drives the motor back and forth. So we're able to set high-low pins, and then that is able to change the direction of this pump. And then we were able to use the existing support structure that is for normally what would be the lid for the sprayer.